Hello, Assalamualaikum everyone. Right now we will present the first survey of 30 students for gender and test two result for business math, which is math 1013. This is for our QMT2043 assignment. Hello, Assalamualaikum everyone. Right now we will present. So let me introduce our group members. So the first one is Aisyah Sofia, and the second one is Sharin Elisa, and the third one is Izzat Harid, and fourth one is Nurisha Mimi, and last but not least is me, Farah Azira.
Our main goal in this assignment is to find the result of examination from businessman data for semester 2 in College Professional Mara, Bandar Melaka. We are using descriptive data because we want to describe the basic feature of the data and present it in the table like pie chart, histogram, bar chart, etc. Our objective is to gain data from 30 students in KPMBM. It's because we want to determine the student level regardless they pass the exam or not. By that, we got to find out what grade they will receive, such as A, B, C, or D. Data collection and preparation. Sampling method. Sampling method are the ways to choose data from the population to be considered in the sampling survey. In sampling, we were choosing simple random sampling method for this assignment. Simple random sampling is a type of sampling method which is give us same chances in picking data and population as a sampling unit. There are usually two methods of sampling, which probability sampling and non-probability sampling. In probability sampling, each population element has a known probability or chance of being chosen for the sample, commonly used of making statistical inference about the population. Non-probability sampling methods, on the other hand, are often used when it's difficult to ensure every element has an equal chance of selection, based on other criteria such as convenience, purposes, snowball, or quota. Purpose of sampling is to draw conclusions about the larger population based on the analysis of the smaller representative sample. The values obtained from studying the sample are referred to as statistics, while corresponding values for the entire population are known as parameters. This distinction is crucial in statistical analysis. As you can see, this is the original data before we are collecting the sample, and this data was given by our lecturer.
We use the simple random sampling method to take 30 data that was given by the lecturer. So this is our data qualitative. There's only two gender, which is male is 10 and female is 20. Next, we use pie chart. Based on this, female gender has the highest frequency of 20 students at 67%, and male gender hold the lowest frequency of 10 students at 33%.
And this is group frequency distribution table. As you can see, the group frequency distribution table, we have marked test 2, number of students, lower class limit and upper class limit, class width, class boundaries, upper and lower, and lastly class mark.
So next, lower boundary and upper boundary as the x-axis and frequency as the y-axis. The histogram shown the highest frequency is 19 with the range 9.5 until 12.5, and the lowest frequency is 10 with range 0.5 until 3.5. We move on to the frequency polygon, midpoint as the x-axis and frequency as the y-axis. The graph shows the highest frequency is 19 with midpoint 11, and the lowest is 0 with midpoint is 2. Okay, this is our frequency curve or GIF. The x-axis is the upper boundary for each class interval. The y-axis is the cumulative frequency. Cumulative frequency 3.5 and 6.5 is 0, while the upper boundaries 9.5 is 7, 12.5 is 26, and 50.5 is 30.
Next, we will move on to calculate the data analysis. The first component of the data analysis is mean. Before we calculate the mean, we have to know the midpoint, which is x. The midpoint, how do we calculate the midpoint? Is basically for each class interval. For example, we choose the class interval 7 until 9. We take the highest number in the class interval, which is 9, minus the lowest number in the class interval, which is 7. And then we will divide it by 2, which will give us the answer 8. So for the midpoint, as you can see in our slides that we have listed, we have 2, 5, 8, 11, and 14 midpoints for each of the class interval. F is basically just the frequency that we have gained from the group data frequency. And the total of F is 30. Meanwhile, the Fx is frequency times the midpoint, which will get the answer 0, 0, 56, 209, and 56. The total of Fx is 3 to 1. So now that we have all the data calculated, we can calculate the mean. The formula for mean is the summation or the sum of Fx over the sum of F. As we have calculated in the table above, 3 to 1 over 30, which gives us the answer 10.7. This means that on average, the students get 10.7 marks. Next, we will move on to the second component, which is the mode. For mode, we have to first identify the class interval that has the highest frequency. As you can see from the table, the highest frequency is 19. So the modal class is 10 until 12. Hence, we use the formula of mode, which is Lm. Lm is the lowest class boundary for the modal class, plus F0 in the bracket, F0 minus F1. F0 being the highest frequency, whilst F1 being the frequency above, also known as the frequency before the highest frequency. After the calculation, we will divide it by F0 minus F1, same as before. But this time, we will plus it with F0, which is the highest frequency, minus F2. F2 being the frequency below, also known as the frequency after the highest frequency. And then, after we close the bracket, we will multiply it by the class width. As you can see from before the final answer, we get 9.5 plus, in the bracket, 12 over 27, close the bracket, times 3, which gives us the final answer for mode is 10.83. Next, we will be moving on to the third component, which is the median. How do we calculate the median? First and foremost, we have to get the cumulative frequency. We get the cumulative frequency simply by adding the first frequency, which is in this case 7. We add 19, which equals 26, and then we add 4, which equals 30. Hence, the median class that we chose is the same as before, which is 10 until 12, with class boundaries that we get from group data frequency, 9.5 and 12.5. We use the median formula, which is Lm, lowest boundary for the median class, plus in the bracket we have n over 2. N being the total frequency. As we have calculated before, the total frequency is 30 over 2. So we minus it with Fm minus 1, which is the cumulative frequency before the median class, over Fm, which is the highest frequency, 19. And then we close the bracket, and then we will calculate it, multiply it with the class width. As you can see from the calculation that we have did, 9.5 plus, in the bracket, 8 over 19, close the bracket, times the class width, which is 3, and that gives us the median of 10.76. Next, we will be moving on to the next component, which is first quartile. For the first quartile, we have to get the position first and add it to the table. And the position is actually determined by the cumulative frequency. As we have listed in the slides, for the class interval 7 until 9, we will have the first until the 7th position. For class interval 10 until 12, we will have the 8th until 26th position. And for the class interval 13 until 15, we will have the 27th until 30th position. Now that we have all the positions listed, we can proceed to use the formula of the first quartile. The formula is LQ1, which is the lowest class boundary for the first quartile. In the bracket, we will have N, which is the same as before, the total frequency, but this time it is divided by 4. And it will be we will minus it with FQ1 minus 1, which is the cumulative frequency before the first quartile, the class that we chose. And then we will divide it with FQ1, which is the highest frequency, close the bracket, and as before, we will times it with the class width. And you can see from our calculation, the value of the first quartile, which is 6.5 plus in the bracket 7.5 over 7, close the bracket, times 3. So that ends it. The value of our first quartile is 9.71.
This is our table that show class interval number of students, which is F cumulative frequency that calculate by adding the frequency. We position them based on the cumulative frequency from the first to the last position. We choose the model class based on the highest frequency, which is 19, and the model class is 10 to 12. Based on this formula, we put the numbers accordingly, and our final answer is 11.95. This is our table that show class. Next, we move on to the standard deviation. The table includes the class interval, number of student, midpoint or x, then fx, x square, and f square. For fx and fx square, we have the total as you can see at the bottom. Then we using this formula for standard deviation, we substitute the value and giving us the final answer is 1.82. We have two formula for Pearson measure of skewness. First formula is mean minus mode over standard deviation. We have got our mean, which is 10.7, and minus mode 10.83 over 1.82, and our first answer is negative 0.07. And for the second formula is 3 times mean minus median over standard deviation. As you can see, our final answer for this formula is negative 0.10. So this is the distribution of our PSK of our sample. As you can see, our value for mean minus mode comes to the negative 0.13, and the latest data is mode at 10.83 followed by median at 10.76, and the smallest data is mean at 10.7, and the distribution is skewed to the left or negatively skewed.
In this part, I will explain about the coefficient of variation. We had compared the consistency of our data set with the other coefficient of variation from each group of assignment among our class. But I will explain how do we get our COV first. We use the formula of COV, which is standard deviation divided by mean and times 100. So our standard deviation that we've got is 1.82 and mean is 10.7. We've divided 1.82 and 10.7 times 100, and we've got 17% of COV for our assignment. So, for the interpretation of this COV that we had compared, group first is the most consistent because of the smallest coefficient of variation at 15%. Then it was followed by group 4 with COV at 17%, and group 2 has the COV of 26.74%, which makes their data with the second most inconsistent. Group 3 has the most inconsistent data at 29.11% because they have the largest amount of COV. In this part, I will explain about the coefficient of variation. We had compared the consistency of our dataset with the other coefficient of variation from each group of assignment among our class. But I will explain how do we get our COV first. We use the formula of COV, which is standard deviation divided by mean and times 100. So our standard deviation that we've got is 1.82 and mean is 10.7. We've divided 1.82 and 10.7 times 100 and we've got 17% of COV for our assignment. So, for the interpretation of this COV that we had compared, group first is the most consistent because of the smallest coefficient of variation at 15%. Then it was followed by group 4 with COV at 17% and group 2 has the COV of 26.74%, which makes their data with the second most inconsistent. Group 3 has the most inconsistent data at 29.11% because they have the largest amount of COV. The conclusion of this assignment highlights its importance in helping us analyze student marks and gain insight into the calculation of student grades. It also mentioned the significance of statistics in this context. Statistics, as mentioned, is indeed a science that involves a various process such as collecting, organizing, presenting, analyzing, and interpreting numerical data to facilitate decision making. In the context of analyzing student marks and grades, statistics also can be a powerful tool. The mention of descriptive statistics and inferential statistics is relevant. Descriptive statistics is involved summarizing and presenting data to provide a clear overview of the information, while inferential statistics involve making predictions or inference about a larger population based on a sample. Both types of statistics have their specific purpose and methods, and choosing the appropriate one depends on the research or analysis objective. Overall, the conclusion underscores the role of statistics of education and the importance of understanding the different statistical methods to effectively analyze and interpret data related to student performance and grades. For the suggestion or recommendation, two methods to improve student performance in business mathematics is implement daily practice, because mathematics practice is important. Once you understand the concept, you have to nail down the mechanic, and often it is the practice that finally helps the concept click. Either way, mathematics require more than just reading formula on page. Second, manage your time. Don't procrastinate your homework. If you fall behind, it takes a lot of additional work and time to get caught up. Other than that, make a schedule that will ensure you are necessary along the way, and at the end of the semester, you are prepared for exam.
And lastly, this is our appendix that we got.